All right, 12.7 here is about normal distributions. This lesson should be easier than any of the ones we've done so far. And they've been getting easier. But they get progressively easier, right? The lessons have been? I think they have been. Okay. Talking about normal distribution. Okay. You guys with us? Yeah, so everybody's waiting on you guys. Yes, it is. Update. The app updated. All right. So, the first thing, have you guys heard of the bell curve before? Okay. Basically, what a bell curve is, it's a curve shaped like not a cat. I was going to say a cowbell for some reason. It's shaped like a bell. Okay? And basically what they're saying is this shows you what percentage of, maybe I'm doing test scores, what percentage of test scores should fall where. Okay, well, your average test score is right in the middle. Okay, because your average, most of your scores should be in the middle. Okay, and then you're going to have your outliers that are progressively better. And then you're going to have like maybe a few hundreds, right? Okay, maybe a few 40s. Okay? You guys get what I'm saying, though? Everything should fall under a bell curve. So there's a lot of times when we take tests and stuff, I'll go ahead and put the data in and see, you like with test scores, your middle passing score is a 75, right? Hey, you like most of your scores to be right around a 75. Yes. As a teacher, you do. Like, logically, I mean, obviously, it'd be great if they were higher, right? Hey, but logically, everything should fall. Your largest majority of scores should fall in this, 65 to 80 range. Or 85 range. It should be most of your scores. Okay, so that's just what a bell curve is. Okay, that's what we're going to be using today with our statistics. Okay, they're going to call it a normal curve because it goes up at the same rate as it goes down. Okay, everything is normal. Basically, you could reflect it over the middle, and it would look the same. Okay, so we're going to be using this for our normal distribution. Okay, first thing we need to understand is all in this green box here. Okay, first of all, your mean, just some terminology so we can understand their diagram, that's x bar, is how that's read. X bar is just your mean, and we know our mean is our average, right? Okay. Okay. Your standard deviation is going to be a symbol that looks something like that. That would be sigma. Hopefully I'm remembering that correctly. Okay, so first of all, okay, this all goes with your normal curve, right? Actually, I'll leave that. Okay, your normal curve, we have a few rules here. Okay, first rule, your total area under your curve is 1. Okay, so your total area is 1. 68% of the area lies within 1 standard deviation from the mean. Okay. I do want you to flip so I can explain the definition of standard deviation. I wanted to say it was like 422. I'll probably be wrong. Yeah, that's not right. Let me find what page that was on so we can talk about what exactly standard deviation is. Basically, it's when you think of deviation, you hopefully think of change. Okay, so you're thinking, how much is it changing? It is on page 446. Okay, so flip to page 446 just so we can look at this definition real quick. This is one of those things we're missing out on by skipping ahead for now. Okay, but your standard deviation, okay, it's the typical difference or deviation between the mean and the data. So what it is one standard deviation is how far is it from the mean to a certain point. Okay, so how much is it changing, basically. Your standard deviation is not constant. Okay, it changes. Okay, so just understand that. It'll change based on what your data says. Okay. The third rule we have is that 95% of the area lies within 2 standard deviations. From the mean. And our very last one is that 99.7% of the area lies within 3 standard deviations of the mean. Okay. Questions on any of that before we start actually getting this drawn? Okay. We do have a general diagram for our normal curve. So go ahead and find a good place in your notes where you can find this. And go ahead and draw a bell curve. Give yourself a decent amount of space. Oh yeah, that's lots of space. Okay, give yourself a decent amount of space here. Okay, I'm going to go ahead, if you want to do so as well, draw a segment across the bottom. It's kind of going to flatten out. Obviously, eventually it'll touch. Okay, but so just go ahead and get it like something like that. Now I've already expressed this. What is the middle going to be? That's your mean. Okay, so that's your x bar. Okay, should you be able to find that all the time? The average of something? Yeah, they're either going to give you the mean or the average, or you're going to be able to find it. Okay, so that would be your mean. One standard deviation is going to bring you over in these areas somewhere. Okay, so what I'm saying is this is one standard deviation this way, and this would be one standard deviation this way. How much area is in here? What percent? 68% of it, right? So this is going to be 0.34, and this is going to be 0.34, because my entire area is 1, right? Okay, so these two together would give me 68%, correct? 34% here, 34% here. Okay? To get to here, I would do my mean plus one standard deviation, right? Or my mean plus sigma. To get to here, I would do my mean minus or plus a negative standard deviation. Think of it as that. You're going negative standard deviation. It's still one standard deviation, right? Okay? It's just in the negative direction. Okay? For our next one, okay, now I'm how many standard deviations away from the mean? 2. Okay, so on the bottom here, this is going to be your mean, or x bar, plus 2 sigma. And then over here, it would be x bar minus 2 sigma, or 2 standard deviations. What was our second rule? 95% lies within 2 standard deviations, right? Well, I'm already at 68%. Okay, so 95 minus 68 is what? Right? Okay, so 27%. Divided by 2 is going to give me each of these by themselves, right? So what's 27 divided by 2? What? 13.5, right? Change to a decimal is 0.135. So each of these has an area of 0.135. Okay, and then these 4 added together would be 95%. I bump one more standard deviation in both directions. Obviously my bell curve isn't perfect here. I messed up a little bit on this right side. Yours is so much worse than mine? That's okay. As long as you have the general idea going on here. Okay, so over here, this would be your mean plus 3 standard deviations, and this would be your mean minus 3 standard deviations. Okay. And we were already at 95%, right? And I know that 3 standard deviations is 99.7. So I need to take 99.7 minus 95, which is 4.7, right? Divided by 2 is 2.35. Move my decimal, and this is 0.0235, right? And this is 0.0235. Okay, so it's only 2.35% of the entire area, correct? And then the rest of it, my other outliers, we won't do the math, but it shows us in our book it's the rest of this over here is 0.0015 on both sides. Okay, so not even a whole percent, right? That'd be 0.15% of the overall area. Okay, so if I was talking test scores, not very many hundreds, right? Few 95s, 95 to 98s, right? A few more of those. Few more 85 to 90s. A lot of 65 to 85s. And then I suppose that'd be like 55 to 65. Less of those. Less 40 to 50s. And then there should be next to none less than that. Okay, is what I'm kind of looking at when I put this into a bell curve. Okay, now remember, this is just your general bell curve. Okay, you are going to need to know this or have this available to you because they're going to ask you how many students. They're going to tell you your total number of students. They're going to tell you what your mean is. They're going to want to know how many students should get in this range. Well, you would take your 68% and multiply it by your total number of students, and that's going to give you your answer. Okay, so we'll start looking at a few of those problems now. It does show you down below in that same example. Okay, understand what it means if it gives you a range of something. Okay, if it's maybe x is greater than or equal to a but less than b, you might have, there's a possibility that maybe you're just wanting this portion, right? Okay, so there might just be one portion that you're trying to look at here. All right, example 1, we're actually using normal distribution. On most of these problems, you're going to want to set up a bell curve. Doesn't have to look good, doesn't have to be pretty, okay, but you're probably going to want to have one drawn. Okay, so I would go ahead and get it drawn. Again, doesn't have to be good. Example 1 says, a survey shows that the time spent by shoppers in a supermarket is normally distributed with a mean of 45 minutes and a standard deviation of 12 minutes. Okay, well, it told us what the mean was, right? So where's that go? In the middle. So you know that your mean right here, that's 45, right? Okay. But then it told us my standard deviation was 12. What does that tell me? So that means that my next bar over here is what? 57. My next bar over here is 33. Okay. After that, I get 69. And after that, this way, I get 21. Okay. Am I done, or should I probably go one more? Probably go one more. Try to go 3 on each side. So then after 69, I get 81. And after 21, I get 9. Okay, so now I have my bell curve set up. It wants to know, question A, what % of the shoppers at a supermarket will spend between 33 and 57 minutes? Yeah, what's the answer? 68%. All based off of this, right? That's 0.34. That's 0.34. That's a total of 68%, right? Okay. I'm going to back this up. Get rid of that. Okay. Part B wants to know, what is the probability that a randomly chosen shopper will spend between 45 and 69 minutes? Okay, now we're talking probability though, right? So first of all, I know my total area is what? 1. Underneath that bell curve, my total area is 1. Okay? My question is, what is this percent? Well, go up to your bell curve. It's 0.34 plus 0.135, so it's 0.475. So what's the probability? 0.475, or if you want to put it as a decimal, you can put it as 47.5%. But yeah, your probability will be 0.475. Okay? So as long as you have your bell curve and kind of understand that, shouldn't be too bad, right? Okay? Eventually, you're going to start getting to the point where you know these numbers. Okay? But for now, keep this so you can look back at that. Okay? We good on that one? That one's not bad, right? All right, the next one, example 2. Okay, now we're talking about a compound event, which means what? Multiple things, yeah. Still going to need a bell curve. Okay, so go ahead and get that there. All right, it tells us, according to a survey by the National Center for Health Statistics, the heights of adult men in the U.S. are normally distributed with a mean of 69 inches. Okay, before you even go on, you should stop right there and do what? I'd put that down. Because your mean's 69. Okay? So I know what the average is. I know that middle part. Okay? And has a standard deviation of 2.75 inches. Okay? So with that, things are going to change a little bit. My first standard deviation goes to 71.75. My next one, 74.5. And then my last one, okay, and then backwards, okay, now I've read those out of the book, but you could do it if you had to, right? Okay, it's just easier with the decimals to just get them down quickly there. Okay, so now I have that. Now it says, if you randomly chose 3 adult men, what is the probability that all 3 are 71.75 inches or taller? So first of all, if I chose 1, what is the probability that he would fall in here? Right? 71.75 or taller. Well, that would be 0.135 plus 0.0235, which is 0.1585, plus 0.0015, and I get what? 0.16? Okay, now that's of 1, right? Okay, what is the probability of this for the second guy? Also 0.16. So I want taller, equal to or taller than 71.75, and the same thing, and the same thing. So what is the probability that I can select 3 men and they all be 71.75 inches or taller? What is it? Okay. So not a very good probability, right? Could happen, but it's less than a 1% chance, right? Okay. All right. The last thing that we need to go over, don't think that means we're almost done, because today's going to be a long lesson. We're going to do the assignment tomorrow. Okay, so just soak all this in. Make sure we got this. Okay, the next part is the green box where it says normal approximation of a binomial distribution. Okay, so what this means is that adding a bunch of stuff together is going to be very difficult. So you're going to go ahead and create it into a normal distribution problem with your bell curve. Okay, so let's just first of all get some stuff down in the green box here. Okay, to find your mean, okay, which is x bar, right? That is equal to n times p. Okay, n is your number of trials, and p is your probability of success of each trial. Okay, so you might want to actually put that down. Okay, n is the number of trials, and p is your probability of successful trial. Okay, so to find your average or your mean, you're going to take the number of trials times your probability of success on each trial. Okay, and then the other thing that to put something on a bell curve, you need a mean and a what? Standard deviation. Your standard deviation is equal to the square root of n times p times 1 minus p. Are these four things probably going to be really important to us? Yeah. So make sure you can find this stuff. You're going to need that. Okay. All right. That takes us to example 3. Okay. Says, according to a survey conducted by the Harris Poll, 29% of adults in the United States say that they or someone in their family plays soccer regularly. You are conducting a random survey of 218 adults. We want to know what is the probability that you will find at most 55 adults who come from a family in which someone plays soccer regularly. Okay, the reason we want to change this into a normal distribution is because of that word at most. Okay, so do you want to know the probability that maybe there's less? Yeah, well then you'd have to be finding the probability of none, plus the probability of 1, plus the probability of 2, plus the probability of 3, all the way up to 55, right? That would kind of suck, yeah. Okay, so we're going to change and we're going to estimate. We're going to go ahead and estimate things and put it into a normal distribution on a bell curve. Okay, because we found out just previously, if something's on a bell curve, it's pretty easy to figure out. Okay, so bell curves are good for us. Now, the question is, I need my mean and I need my standard deviation. How do I find my mean? It's the number of trials, which would be people in this case, right? Times, so I have 238 times 0.29, because that's the probability of one trial being successful, right? Okay, so what is 238 times 0.29? 69 point what? 02. Okay, so my average or my mean is basically what? 69. Okay, go ahead and give yourself a nice rounded number. it'll make things much easier. Okay, so there's 69. Okay, so we rounded that. Now I have to find my what? Okay, I have to find sigma, or my standard deviation, which I know is the square root of n times p times 1 minus p, correct? Okay, well I already did n times p, so I have 69 times, which is 0.7, sorry, yes. 0.71, okay? Well, 69 times 0.71 is, and then square root of that. Basically 7, right? Wait, once it's all reduced, will you get the door, please? Okay, so my standard deviation is basically 7. You guys agree with that? Okay, so when I go to the right, 69 plus 7 is 76, plus another 7 is 83, right? One more time gets me to 90. 69 minus 7 is 62. Minus 7 is 55. Minus another 7 is 48. Okay? So now I have my bell curve set up. Now we can start assessing the question. Okay, we want to know what is the probability you will find at most 55 adults who come from a family in which someone plays soccer. At most. Okay, so do I want 55 or more? No. At most means I want 55 or less, right? So I just need to find what is this, the probability that happens. Okay, go back to your normal curve. That's these two, right? So I have 0.0235 plus 0.0015 0.025, right? So my probability that I find 55 or less, or at most 55, is 0.025, or 2.5% chance. Okay? If you can change things into a normal distribution bell curve, they turn to be pretty easy. It's a lot easier than finding the probability and adding them all together. Okay? Okay, you have 12 minutes here, so I'm going to go ahead and tell you the assignment for tomorrow. I want you to go ahead and start working on it. When class ends, you don't need to do it for homework, though. Okay? That work for everybody? If you want to do it for homework, you can, and then you'll have study hall tomorrow. Up to you. Completely up to what you want. Okay, so that's what we'll do. It'll be due on Wednesday.